I don't think it's a shock to say that many of us here are passionate about attack and how we're going to use it in our environments, or how we are using in our environments. And our next speakers really embody this ideal. Roberto Rodriguez is a senior threat hunter at SpecterOps, where he specializes in the development of analytics to detect advanced adversaries techniques. His experience performing incident response and threat hunting motivated him to help organizations improve their security posture and to share his knowledge with the information security community. He is the author of several open source projects, such as the ThreatHunter-Playbook and HELK, to aid the community development of techniques and toolings for hunting campaigns. His co-presenter is his brother, Jose Luis Rodriguez, a student at Northern Virginia Community College, where he just started his associate degree in cybersecurity. His background in business intelligence and data science for large organizations in Peru motivated him to apply his experience here in the cybersecurity industry, and he is also a frequent contributor to open source projects. Please welcome Roberto Rodriguez and Jose Luis Rodriguez.
All right, thank you very much, everybody. Can you guys hear me? Well, okay. And first, I would like to say thank you to the attack team for giving us the opportunity to be part of the first ATT&CKcon, and also, of course, to be able to speak with my brother for the first time. And the topic today is going to be hunters attacking with the right data. So the focus, or talking about hunting, is going to be focusing a little bit into how we can start using what attack provides from a data perspective, and then start mapping things to what we're collecting already in our environment. And we were already presented, part of the SpecterOps team, and the GitHub link is there. So if you want to contribute, please, I would love to talk to you and brainstorm a little bit how we can do things better, and also a former Capital One senior threat hunter.
Hi, everyone. My name is Jose. I go by CyberPanda in Twitter. Very happy to be here with you. This is my first conference, and also a funny thing about this is that my first cybersecurity word that I learned in January when I came here to the States was attack. And I'm also a former senior business intelligence analyst from OSSEM, Peru.
All right, so the agenda for today is going to be talking about what we're seeing, or what I'm seeing most of the time in organizations, from a threat hunting, from data perspective, from attack as well, all the way to start showing you how we start mapping things, specifically event logs to attack data sources, show you a couple examples at the end how that works. So from a threat hunting and data perspective, I see that every organization has its own procedures. They want to do their own things, they put together their own programs, and it's great. But at the same time, I see that the focus on data is not as important as I believe it should be. Data, as we know, first is growing. It's getting bigger and bigger and bigger. And if we don't start documenting our data, understanding what that actually means, what that provides to us, and finding relationships in there, it's going to be hard to start hunting. It doesn't matter how good your program might be. You might be hunting in a data swamp rather than in a data lake, which is what we all intend to do, right? We all try to buy these tools, try to put them together, but at the end of the day, it might not be an ideal situation. So more data, more problems. I think that some of you might be thinking about this, but the reality is that more data gives you enough visibility, right, from a hunting, from an IR perspective, but you have to start prioritizing what you collect. You have to start understanding what you have. And the first question of what data do you have in your environment, most of the time, of course, is answered by, I do know where my data comes from. I do know my logs, where they come from. But the second question, do you really know your data, the data that you're collecting? That's a different question, right? Do you understand the meaning of the logs that you're collecting? And of course, at the end, we can start going back into this conversation, but do you really know your data? Right? So this is the whole idea of this presentation. We all know why we're here, right? Attack provides a lot of information, great relationships across all the data that they put together. But I believe that we're still missing that piece from the extra metadata that attack provides that we love the most, which is the data sources piece. And if we define data sources from a MITRE perspective, just to summarize this thought, is that it's the information that you collect from the sensors and things that you have in your environment, all the way to the perimeter level, that is going to allow you to validate the detection of a specific technique. So when you start understanding this, you start then creating these extra relationships in this beautiful first relationship that they put together in their paper, with the main goal to start mapping things that you have all the way to a technique, to an adversary, and things like that. Now, this is easier, right? Because you can just say, this tool gives me this, I bought this vendor, it's giving me this. So you can do this. So your question might be right now, then why we keep talking about data and how we can map it to MITRE ATT&CK? The main goals is that what we want to do in here is to expand on the attack data sources. We want to help prioritize how we can start collecting data, still map it to an attack data source, but in order to be more efficient doing that, we need to understand how pretty much we can talk about our data, understand it a little bit better. At the end of the day, we're going to define a methodology, how we do this, in order to help blue teamers and also red teamers to understand what an adversary actually look like in the environment. And of course, we want to share how we learn about event logs and also data sources. So let's define our methodology. We're going to go all the way from exploring attack data sources to start validating these data mappings and, of course, sharing our methodology. Let's explore attack data sources. You might be asking yourself how I do this. And there are different ways to do it, right? You can do it through the website. You can do it through the GitHub repo. But the one that I like the most is to do it via their public taxi servers, using their APIs to then access the data in sticks format. So we built this library on the top of the two other MITRE libraries that were out there for the community. The reason why I built mine was because I wanted to keep the same naming convention that you see on the website when I collect all this data, because the sticks tend to change a little bit, the names and all the stuff. And instead of calling it a technique, you might be calling it this attack pattern. So that's why I like to keep things more consistent. That's the only reason why I built this tool. This tool can be installed. This is just for reference for you guys. You can do it via pip from source. And then after you do that, you can use Jupyter Notebooks to start manipulating the attack data sources and all the information that you get from attack. And as you can see, it was just updated yesterday. After the big updates, some of the things broke in my scripts. So I had to do it again and update it. But actually, that helped a lot for our next conversation, because we were able to put together an updated Jupyter Notebook with the latest numbers from MITRE ATT&CK, especially from a data source perspective.
Yeah. So after updating our Jupyter Notebook, we found 478 techniques. Most of them, actually 259, do not have data sources. And this might be an opportunity for us to collaborate with the attack team. Or maybe because some of them do not happen inside your environment where your security tools are collecting data.
Yep.
Now, so if we group all these techniques with and without data sources by matrix, we can see on the graph on the right that all the techniques without data sources, most of them belong to the pre-attack and the mobile attack matrices. Now, something interesting that we found here is that there are 4 enterprise techniques that do not have data sources. So if you were looking for something to do this weekend, this is the list of the 4 techniques that do not have data sources.
Collaboration right there.
Yeah.
If you really wanted to do something this weekend,
yeah,
there they are. Yep.
Now, let's focus only on those techniques that do have data sources. So the majority of these techniques are covered by 3 data sources: process monitoring, process command line, and file monitoring. So this might be a good start if you want to prioritize your data collection process. Another interesting thing at looking at this graph is that there are some data sources names that are related to the Windows platform. So let's analyze these Windows data sources and analyzing every data source that is mapped to a specific technique. We can see that some of them are related to non-Windows platform. So we need to be careful if we want to map a specific data source to a specific technique, to a specific platform. There might be some information that doesn't make sense. Now, going back to our graph, some of you might be prioritizing your data collection by considering the data source that covers most of the techniques of the attack framework. But do we really need only one data source to validate the detection of a specific technique? Well, our next graph will help us to understand or to answer this question. According to the MITRE ATT&CK framework, only 19 techniques require one data source. And so the other 200 techniques require at least 2 data sources. So the number of data sources for us is related to how much context you need to validate the detection of a technique. So we are not talking about just only one data source. We're talking about groups of data sources. Now, here is the list of the top 15 groups of data sources that the attack team recommends to work together in a specific technique. So as you can see here, the top process command line, process monitoring, and file monitoring belong to the top 4. Now, we know that we were talking about these data sources before, but now we are not looking at them just one by one. We are looking at them as a group of data sources. So, for example, with file monitoring, process command line, and process monitoring, and process command line, and file monitoring, you can start analyzing at least 37 techniques.
Right. That has to be as a group and not just as one, which is the main point in here.
And this can be another way to prioritize your data collection process.
All right. So once we learn a little bit into what attack actually provides to us from a data source perspective, then we want to start documenting some of the things now that we have in our environment. Let's pick this technique right here, T1214, credentialing registry. We do have these attack data sources already defined for you. The first step, you might be already saying, okay, if I want to detect this, at least to validate the detection of this technique, I'm going to use 4688 because that maps to a process creation. But the reality is that there is other events that are part of process monitoring. In this case, 4689. You might have other data sets such as Sysmon with process creation. They give you more information that probably 4688 might provide to you, all the way up to, for example, a process accessing a process. So the main goal in here is to understand what you are getting from the data rather than say, oh, this gives me a process, and then you say, cool, so we're checked. No, you have to understand how that actually works. And in order to do that, the main step in here is to start creating data dictionaries. You have to understand exactly what each event field provides to you. And in this case, we have the event ID 1, so you have some ideas. This came from also a research from red teamers. SpecterOps, Matt Graber, and Lee Christensen, they talked about a Black Hat, how they were able to document what Sysmon provided to them. And they were able to see which specific event fields were a higher attacker influence rating. So these are the specific event fields that they were sharing that they could manipulate and pretty much own. So that's very important. So if they are doing it, we should be doing it as well if I haven't convinced you yet to start documenting your data. The next step is to build a data model once you document all the stuff. This is because we want to define the structure of the data and we want to find relationships among all these different data sets. And MITRE started their own data model and also the links for car analytics and also the specific cyber observable objects that they use, information. So if you want to understand it a little bit more, go to those links. You're going to have a lot of information. Most of our research is based on that as well. So when you start talking about data modeling, you might be thinking from a database perspective, okay, conceptual all the way to physical, so basic entity relationships all the way to specific data types that you use to store your data. Okay, so that's for those that have that knowledge. But this also applies to cyber threat intelligence, all the way from a relational database perspective to some graphing that you can do with data from CTI. And from here, you can then go deeper and start getting information such as properties or specific adversary attributes and things like that. So why can't we do that with event logs? We can start then pulling file, a process, a registry, a pipe. And then to that, there are going to be relationships among these specific data objects. You're going to find properties, attributes to these specific data objects. And if you document your data, you might find specific relationships already defined for you that you have to use in order to do these correlations. We were talking about join queries. We're talking about sequences of events. You have to document your data and start modeling so you understand what that actually looked like. The idea at the end is to start building something like this where Sysmon can be, instead of showing all these beautiful event IDs, now you're going to start showing that in a relationship way between a process, creating a process, a registry, a file, connecting to a pipe. So you have to be able to understand your data this way because this is going to help you later to build your data analytics.
Okay. So after documenting all the relationship between our data objects, we can start defining sub-data sources that will help us that will give us more details and information about each attack data source. and will give us the relationship between an attack data source and a data model.
So after that, you can start backing up each specific sub-data source. We're talking about sub-techniques, but I believe that in order to accomplish that, you have to understand how the data will define what it is that you can detect. So in here, we can pretty much apply our basic model and start putting together what a sub-data source actually means from a logic perspective. And at the end, you can do the same thing with Windows Registry, for example. And something very interesting here is that that's what Sysmon provides to you, right? Process to a registry. But Sysmon does not give you user to a registry relationship. You have to do that with security event logs. So that's very important because you might just be stuck in here, and then when you try to come up with this next analytic to start identifying users doing all these behaviors, you won't be able to do it with Sysmon. So you have to understand what events are going to provide that to you. The idea at the end is to start creating this whole mapping, right? And before we were talking about all the way from a technique to attack data sources to sub-data sources with this specific model. Then once I do this, then this to me makes sense. It's not anymore based on feelings, based on expertise, and saying, I know this tool gives me this. Yeah, I work with this. We're covered with registry. You buy this tool, we're good. They say that they cover process monitoring. Wait a minute. What specific sub-data sources of my process monitorings are you covering? Only process creation, or you're going all the way to a process accessing a process? Correct?
So going back to our top 15 groups of data sources, let's pick the second one, which contains file monitoring and process monitoring. This pair of data sources are together in at least 68 techniques. So applying our methodology, you can see here the relationship between an attack data source, sub-data sources, and event logs. Now, the question here is, do we need to collect all these event logs? So the answer is it depends of the variation of the technique that you are analyzing. So in this case, for example, we are only considering 4 sub-data sources and 4 event logs. And this, for us, is a good example of being effective in our data collection process.
Yep. So the idea at the end, I know that a lot of you might not like Excel sheets, right? But this is very easy to keep track of just with an Excel sheet. If you want to now be a little bit more dynamic and start using some like text search functionality on the top, I can push this to an Elk stack and just give it to you, which is going to happen after this presentation. I was thinking about that. I was like, how can I not show a spreadsheet and show an elastic dashboard? So this is going to be available in OSSEM. This is our new logo, by the way, because we love animals. So we like to put together like a little logo for each project that we work on. And this is going to have data dictionaries, the whole data model aspect, attack data sources mapped to specific event IDs and things like that, but not just the direct relationship between attack data source and event ID. We're going to show you what happens between that relationship and why we believe it should be that way. We have at least, I think, 100 event logs with relationships that we have in there, and that's going to keep growing and growing, and of course with the community involvement, that'll be nice to expand it. So we're going to show how that's actually helpful for your threat hunting operations. Everybody has their own procedures once again, right? There is different ways that you can do this, but this presentation focused a lot into where data might fit. And I think that what we talked about in here from a documentation and data modeling perspective happens before you even build your data analytics, because you have to understand what it is that you need before you build your data analytics. And this happens, of course, after a simulation. So for those great companies like Endgame and Red Canary building their own simulation tools, it's awesome because you can then have that data, model it, document it, and then build your data analytics. And before you execute a hunt, you have to then, with that information, do some type of completeness, data quality assessments. How much data do I have now that I want to go in production? That will define how successful you will be in your threat hunting engagements. So keep that in mind when you talk about data. Make it a big point in your program. Think about it, document it, and it will be really helpful. So we're going to do one example in here, and we're going to pick pass the hash. That was actually perfect to be here because I can point it out. And pass the hash in general, just the basics is how you can authenticate to a resource by using just a hash or a key, so without typing your credentials. And there is some variations. There's one called overpass a hash. This is just based on Kerberos authentication. I'll talk to you a little bit in my 1-minute definition of what it is. Actually, less than a minute. And then it's just based on tickets and keys. And then the idea here is how you can take a hash of a password and then upgrade it to a ticket. It's going to make sense in a little bit. So Kerberos authentication in here, the basics, you type your password, it gets hashed, multiple keys get created depending on the functionality of your domain. You can take that hash or that key and then request a ticket. You get the ticket because they validate that it is who you say you are, that you are who you say you are. And then with that ticket, you can access other service tickets to access other resources, like a file share, things like that. That's the basics of Kerberos authentication. There is, of course, more about this. Overpass a hash avoids the first step, which is do not provide, they don't provide the clear text password. If the attacker steals that hash or that key, they can do this whole requesting of a ticket, then getting a service ticket and things like that. So let's just take a look at Mimikatz because they can do that, right? And this is not new. This has happened a long time. I actually did a blog post about this. And what it does, it creates a new process with fake credentials. Then it patches LSAS with the key that it stole. And then you can start pretty much impersonating and accessing resources that the user's key actually has access to. So in this demo, we have Mimikatz. We have our account Pedro. It's actually my dog's name. And we have a hash, and we have a target. This is the victim, and he's running as admin, and we have the target. And if we pretty much check who we are, right, we're just basic C Brown. It's just another user. And if we try to access the domain controller or just any other server that the user does not have access to, access deny, basic stuff. But then what I can do is start using Mimikatz overpass the hash in order to access these resources that I want, because now I have Pedro's hash. So we just copy and paste that command, and then we can see that first a fake process gets created, fake credentials are there first, then the hash gets patched to LSAS. So now if we do another who am I in this process, we still see Brown, we're still the user, but now if we try to access the domain controller again, for example, then we can see that it was successful. So this attack is very interesting, right? Because you can just impersonate somebody without using those credentials. And let's just start using this methodology a little bit. So we start getting all these event logs, and in this case, we're getting a process calling a service with privilege, with specific service privileges. We can see LSAS doing the same thing, and in this case, it's because LSAS is getting ready to start managing this Kerberos authentication. We see a user authenticating to a host locally. It's because C Brown now has a new logon process with other credentials that are going to be used over the network. So we have C Brown, and then we have Pedro there, that the moment the user accesses a resource on the network, then it's going to use Pedro's credentials. And then, of course, what Mimikatz does best, access LSAS, and it can patch the specific key to LSAS. And then at the end, LSAS gets ready to start doing this authentication, so a process binding to a port, a process connecting to an IP via a specific port. So now we're kind of like telling this story a little bit, just using our data modeling concepts. And then this is very interesting. Sysmon Event ID 3 gives you that information that you saw before, a process connecting to an IP, but you do not get user information in this event log. You get it with Event ID 3. So if you want to do a use case about users and processes together as a relationship, you need a different event log, okay? And then we see 4648, the moment the user wants to authenticate to the specific resource, then it's gonna be using explicit credentials. And then we see the whole ticket, there it is, authentication in there, all the way to the ticket, the service ticket. And then we have the user authenticating to the box, and this happens on the server side. So as you can see, Pedro is authenticating. It's not C Brown anymore. So we are trying to understand what we get and document it and building the relationship in that specific log, because that's going to help us for our data analytics. And then we see the user accessing a network share and things like that. So now I'm going to show you another variation real quick, which is with C# Rubius project from our coworker Will Schroeder, Harmjoy. And then he pretty much started building this tool that does not touch LSAS. does not let LSAS doing all this Kerberos authentication. It crafts the traffic and then does this whole ticket request and response. It's very interesting in here. So let's just do it again. So we have our tool in there, and we do have our hash and our target. We're going to do these same steps just to show you that it's not being run as an admin. It's just a regular user. And this is actually one of the beautiful things about this, because you can run this without being admin, because you're not touching LSAS, you're not patching LSAS with a new key. So we're doing our basic test. Access denied, of course, same concepts. But now if I use Rubius, it's a C# implementation of Delphi's KeyCube project. We can just use the hash of Pedro again, and then we run it. And then from there, what is going to happen is Rubius is going to manage all these, like sending the key, getting a ticket. As you can see, it's doing this whole request, and then gets the ticket back, and then imports that ticket into the current logon session. So now, without opening a new process, we can access the domain controller. So in here, we're going to start looking at a couple of different events, similar, but something interesting is that we jumped straight to the authentication events. We didn't do anything with LSAS in between. And in here, we see Rubius getting ready to talk to somebody. Rubius talking to the domain controller via port 80. And all these maps to our modeling on the top with a specific sub-data source. Once again, information about a user with Sysmon event ID 3. And then the same concepts with the ticket request, service ticket request, authentication to the server side, all the way to accessing a share. The interesting piece about this is that LSAS was managing the authentication first, but then now Rubius is doing it by itself. So if and here we provide more information about the user. If we throw this logic to 3 million events, just network events in a regular lab, this is for our class lab that we do for a whole week. Only 29,000 events happen, processes talking to port 8080, which is Kerberos port protocol. And we see that LSAS is the only one doing it. So the moment you just run Rubius, then you pretty much stick out right away from a network perspective and process to an IP and to a user. But the idea here is that I was able to see that with this event log, I can start creating relationships on what users are accessing my servers or via port 88 that are not system and is not LSAS, for example, from a user, from a process perspective. The idea here is to start mapping our methodology to what we saw during this simulation. And we can see that Rubius uses different, less sub-data sources and less specific event IDs. And that's just because of the nature of the tool. So instead of modifying attacks data sources, because I'm not changing the first one authentication logs, I'm at least giving you some details into what it could be. And then we also have some extra data sources that would allow us to also probably contribute to the attack framework, because those two data sources at the bottom allow me to get more context and get to the network piece of, of this attack. Thank you very much.
Muchas gracias.
Thank you.